Hey, we are live. There we go. This is yet another Ask Us Anything session. Today we have Scott in the audience. He claimed that he cannot come and be my guest in the show. Shame on you, Scott. Anyways, we have Endre Sara here. No, Endre Sara, I think, from Causally. You want to introduce yourself? He's here to help answer any questions you might have. So go, Endre. Very quick introduction, 2 sentences.
Hi, Victor. First of all, thank you very much for having me. It's such a pleasure. I enjoy your show so much, and I hope we can answer any questions just in 2 seconds. I'm a co-founder at Causally. We started Causally 2.5 years ago. We are now having an increasing number of paying customers, which is amazing. I'm happy to talk about that in another context, but here we are answering any questions that come up. I've been in this space for, I don't know, maybe several decades, so let's see. I probably don't know most of the things that I should know, and let's have fun.
Cool. There you go. You heard it. So start typing your questions. Ask whatever you want. We have no script. We did not prepare anything in advance. It's your questions or nothing. So shoot for it. Now we have already one from Mohammed. Do you think Cilium network policies are better than Kubernetes network policies? Let me give you my 2 cents and then I'll let Endre churn in if he has anything. By the way, sometimes the answer is I have no idea. In this case, I do. So think of Cilium network policies as extensions of Kubernetes network policies, right? You can have Kubernetes network policies and you should have Kubernetes network policies. And then if you come to the situation that that's not enough, you want to accomplish something outside that, you can resort to Cilium network policies. And I see that in a similar situation as we are now with, let's say, more generic policies like Caverno, right? Caverno is great. It's amazing. Still, right now you have, since maybe a few months ago in Kubernetes, Kubernetes validating admission policy, which might fit all your needs or might fit some of your needs. And if it fits some of your needs, you can either say, hey, I'm going to go fully on Caverno, as example, or I'm going to cover with additional tooling like Caverno the missing pieces, right? So it's not one or the other, that one is better than the other. Cilium, I see it more like extensions of each other.
Yeah. I think that I don't know if this is helpful, but I think that it's really interesting to watch the evolution in much of this technology, specifically in terms of Kubernetes APIs, where people are kind of iterating on like, what do I want? And then there's like what version of an API, and then you mature the API, and then you either end up with a perfectly good coverage of the API, but with a pluggable implementation, or you just end up with like, this is just becoming part of the platform. It's so good that, we just want to provide this out of the box for everybody. And I think it's interesting how that is evolving with network policies, and are the functionality becoming pluggable, like Gateway API, for example, or is it becoming just part of, something that everybody is using because it's so common? And I think it's exactly what you said, Victor, is to see what is it that you need. You should have network policies. How far do you need to go?
Okay, the next one from Alex says, if one does not have enough resources in the local laptop to run local Kubernetes dev environment, what approach is recommended to run such environments remotely? I would probably, out of the bat, without thinking much about it, group those environments into 3 different categories, right? One would be something like dev containers that allow you to have what you would normally have on your laptop remotely, right? Basically, it's a VM. It's a container running in a VM, or container or VM without container, whatever else is. It can be many different variations, and you get your same what you have locally, give or take, including ID somewhere else. You don't have to care about resources as long as you have resources there. That's the simplest and most common one, right? And the worst one, in my opinion. Then you can have something like Octeto, where basically what you're doing is saying, in this scenario, let's say that you're running Kubernetes, right? So with Octeto, you're saying, you know what? I'm going to take that application running in a cluster. And then Octeto is going to modify it slightly, but it's going to be almost the same. and it will synchronize my code with that remote application. So that whatever I type locally, it's automatically propagated to that cluster, right? It's not necessarily even specifically development environments. It literally replaces container in one application while maintaining service, ingress, virtual service, whatever else you're having, and continuously synchronizing code and building it there and so on and so forth. Now, the problem with that, or with remote environments in general, is that they can be expensive, right? Because you need to pay for that CPU and memory and disk and what's not remotely, right? The third option is to do with networking, right? A good example, lesser known, but my favorite would be MirrorD, which basically allows you to run your your process locally. Everybody can run their single application locally these days. But then you configure your external cluster, let's say staging environments, to forward requests or to steal requests and to do things so that it feels like your local application is in a cluster, and more importantly, it's connected with everything else. Because it's not really, usually it's not a problem with your application. The problem is that your application is a database, and if it's a backend application, it's frontend, and it might need nuts of Kafka and stuff like that. That's a problem, right? And the second and the third group of solutions solve that problem. I don't know what's your experience with it, Endre, but
yeah,
those are the options I see.
I absolutely. I've done built a couple of environments where the local code is being constantly parsed, and for the most part, you could get a functional environment with the appropriate, like whatever language you're using. Is it continuously rebuilding, or how do you reload? But I think that's one of the options. I think it's a lot of fun to tunnel back and forth between the majority of your microservices are running in some non-production environment and just tunneling out or in and out one of your microservices. I think I had a lot of luck proxying front-end to back-end, and the complexities of tunneling individual microservices and the interaction between those microservices was a bit more cumbersome for people to manage, because like I need to access the database, but then I need a local Kafka, or do I need a remote Kafka and a local database, or do I anyway? So there are some complexities in understanding the backend interactions and being able to plug out one service and then be able to connect back to it. But if you're dealing with a large, complex, preferably microservices architecture, and you only want to work on one component, that's actually a workable solution. I don't know how to offer that as a platform. What do you think?
It's depends on the tools. I strongly suggest checking MirrorD. It's really awesome. It you just create a simple config, and it says, and it will figure out how to do, what to do, where to send, and it's mostly based on networking. And it's awesome. I think that I will have actually another video on that, like in a month of time or something like that. So stay tuned. Now, before we continue. This is about paying bills and stuff like that. We have a sponsor here, Codefresh. So if you're interested in GitOps and you want to learn about GitOps, you want to be certified in GitOps, you want to do whatever GitOps, go there for two reasons: because it's awesome. Second, because if they see that you're going there, then they will continue supporting the channel. So learning at .codefresh.io. Type Victor over there when you are subscribing, whatever you're doing, and you will get the discount. Thank you, Codefresh, for sponsoring this stream. Let's go back. See, I'm not good at selling stuff. So the next question from Scott, Infiltrated. If you could get your way, what would be the one major change you would want to see made in Kubernetes? You want to go first, Endre? Do you have anything you want to see changed?
Well, I think that, I don't know. One thing.
Okay, while you're thinking, let me give you my one thing. And this will sound confusing and not necessarily easy to explain, but I want better propagation of information from child to parent resources, right? So we are getting really good in Kubernetes at creating abstractions. Like, for example, deployment is an abstraction of a replica set, which is an abstraction of pods. I'm not even talking about custom, right? And then you say, hey, I can create a deployment. Cool. And that's so much easier than managing 100 pods separately. Cool. It's great. Now, if you want to see whether it's running, or if it's not running, what's going on, you will not find information in the deployment, right? You will need to know what are the low-level details. You will need to find the replica set, and you will need to find the pod to find out what that is. And the reason why I think that's very, very, very problematic and needed in Kubernetes is that many of us are building our own abstractions, right? Of one form or another, for applications, for databases, for servers, for whatever. Creating abstractions and saying, hey, you know what? Here is this something, whatever that something is. I'm using Crossplane, but that could be Crow, that could be Helm, whatever it is. It's very easy. You just fill in those 5 fields and off you go, right? And that's brilliant. I love it. But that's day 1 operations. Now, you get to day 2. Oh, something is not working. And all of a sudden in Kubernetes, as it is now, you will not get the information what's not working at that level of abstraction, right? You will need to know all the low-level details. And then you say, okay, but why did I use this abstraction in the first place if I still need to know everything about everything to find out what's wrong? So some way how to propagate, not all, but the relevant logs, relevant events, relevant statuses back to what somebody created would be awesome.
I mean, my first reaction was, it's not that I want to change it, but I really appreciate the whole controller pattern. And I think the more things that are moving out and moving behind an API with a choice of the implementation gives people the ability to use the right set of technologies through the same abstraction, which is kind of like the thing where you're going, okay, now I have the right level of abstractions built on top of each other, and you started from the consumer perspective, but I'm starting with the provider perspective of like, how do I develop my operators in a way that they are properly and consistently controlling the thing. And the interesting contradiction is what you're saying would be so easily interpreted or misinterpreted is that I'm just going to populate everything up to the customer API, but that's a mistake. Because the whole point of the operator is to hide that complexity. So not only to be thoughtful about the controller management of the child resources, but what is it that I actually want to expose? What is it that the consumer of this API have the ability to influence? What I mean, I can tell you that, like, you know, my node is not ready, and that's why I can't schedule the pod. But if you can't manage the nodes, it doesn't help me to know that.
Exactly, and that's why it cannot be a solution generic solution that is applied to all cases. It needs to be the decision of somebody. Okay, so in my organization, you can or you cannot manage nodes, right? I'm using your example. And if you can, then I'm going to propagate that information. And if you cannot, I will propagate some other information. That information will be called Joe. Joe can do it for you, right? Kind of like you cannot do it. So that needs to be somehow custom because it differs from one organization or another. What is it that consumer can and cannot do? And it's a tough problem. I haven't seen it really working completely. Okay, another one for Scott. He's on fire. What are your thoughts about TCS? This time I'm going to let you answer. And the main reason is because I promised to myself that I will not swear and use horrible words on this channel.
Well, and you're expecting me not to swear?
Yeah, you're a guest, kind of like, who cares? Kind of like...
Well,
you can always say that I never informed you about not using certain words.
I don't swear to begin with, but I am very tempted. And okay, so let me just say it up front that I am very biased. I've been working in Kubernetes for a long time. I am familiar with it. So my first non-swearing comment is that, depending on what you're familiar with, if you are more familiar with ECS and the patterns and deployment, that may sound more familiar. Someone who is coming from a Kubernetes background, there are significant differences in terms of how you define your tasks, how do you manage configuration, and switching between the two is not obvious. So I actually literally just spent this week deploying a couple of things on ECS, and partially because I am more familiar with Kubernetes, it's painful, and I probably was swearing. I'm not going to repeat those swear words, but I did not enjoy the experience. I find it more constraining, and again, I'm saying this with a bias that there were things in Kubernetes that I think are possible, that I think it should be possible. Like, how do I manage configuration and without copying it from an S3 bucket? I think that there should be better solutions. Or anyway, so personally, I think that there are also broader adoption of Kubernetes. So if you're trying to get help going forward, I think it's going to be increasingly easier to get help with a Kubernetes-based deployment of your application. So even if at face value you could solve the problem in both places, it's going to be harder in ECS for anything in the future.
To me, that's the more important argument than whether ECS is better or worse. We are at a point where I don't see it as what is better option, right? I see it as almost every single software vendor on this planet chose to rally around Kubernetes, right? And most of us are creating solutions, whichever solutions we're creating, first and foremost for Kubernetes, and then maybe eventually for other platforms later on. And that means that apart from you being locked into something that is potentially not as good and still proprietary, that aside, right, you would be missing on most of the innovation happening if you're on ECS, right? Like, hey, look, I don't know, service meshes, right? Kind of a whole load of really cool things are happening on a networking layer, and you're out of it, right? You cannot benefit from all those things. So the question is, not the question, but the statement is that it almost never happens in the history of software engineering. I think it never happened so far that almost everything from the vendor perspective, not users, rallies around a single platform, right? And that happened with Kubernetes. And ignoring that and not using it is bad idea compared to ECS. Now, I'm not saying, hey, if you want to use Lambda, actually, this is the second question here. Need to move to Kubernetes and eventually support multiple environments. How would you plan a migration to Kubernetes with an existing AWS-centric deployment? Lambdas, step functions, ECS, RDS, and so on and so forth. And that, I'm just continuing the thought from the previous question, right? I do not necessarily think that everybody should move away from Lambdas into Kubernetes. I don't think that necessarily that people should stop using RDS and run databases in their Kubernetes cluster. Maybe they should, maybe they shouldn't. Separate story, right? But ECS is a direct competitor of Kubernetes, right? And you should be moving things that you have in ECS to Kubernetes. Now, how to do it? I don't think I can answer that in a few sentences, right? Depends on what you're doing. But you don't necessarily have to move away from Lambdas. Lambdas, for certain cases, not all cases, but for certain cases, Lambdas are great. And you're probably going to have better experience with Lambda than if you run some type of serverless yourself in Kubernetes and so on and so forth. Not all serverless, but function specifically, or RDS. RDS is great. But ECS, move to Kubernetes. How to move it? Well, long story, step by step. And another thing I should say is that you should also, and this is me now being very, very biased because I work with Crossplane, and that's that there are two usages emerging from Kubernetes. One is a thingy that runs your containers, your application. That's a replacement for ECS, right? Another thing is a place from where you manage stuff, whatever that stuff is, not only containers. And you can still say, hey, I'm going to manage that RDS from Kubernetes. And that's a perfectly valid option, right? But not necessarily to move away from it. Yeah. You just churn in. I'm not going to ask you what you think.
Good. It's good. One of the things that I've done in a couple of places is that I try to create some flexible options to be able to use different managed services as an option. So again, I am biased, so I started out with something that runs in Kubernetes, and I said, okay, you could plug in this RDS or that RDS. You could self-host it or use the managed service. You could call this function here or there. You could expose it through this ingress, through this load balancer, or through a service mesh. So I think that trying to pick apart what you're running in AWS and then trying to define, like, okay, these are the pieces that I can move by separating them. It's actually work to take that separation to be able to say, like, okay, this is the boundary between RDS and my application, but it gives you the ability to not be locked into one thing. And then, especially when in the previous company, we provided packaged software, we needed the flexibility to be able to plug into different environments, different managed services, different cloud providers, so it paid off. But I think even when you're developing your own self-hosted service, there is a benefit of creating that separation to be able to move the pieces and replace them somewhat transparently. There's an assumption of, like, this is the good thing about RDS. I can get Postgres, I can get MySQL. It doesn't matter if it's MySQL or Google Cloud or self-hosted. So I can just say, this is what I expect. Provision me a managed database service, and here's the interface to do this. Maybe that's not as clean with lambdas, but I think that there is some way of calling a function, some API gateways, whatever, that you could find some way of abstracting and then kind of moving things piece by piece. And then giving the flexibility to keeping something in place and then maybe moving some things in. ECS, I don't know. Same thing what I said earlier.
We're in agreement about that one. Okay, the next one. Would launching Kubernetes nodes for instances be considered poor man's chaos engineering? Now, I'm not sure I understood whether the question is whether you should be doing chaos engineering on spot instances, or that's a reference to kind of would we expect it to be failing all the time?
Let me try this. I think that if you're developing software and you're running that software on spot instances and your service degrades, then you probably wrote bad software. So I think it's a good idea to run on spot instances. I don't necessarily, I mean, you could call it chaos engineering. I just think that it encourages better patterns in the way that you're constructing your service. So I actually prefer to run things on spot instances, but I can't say that I'm perfect. There's a bunch of places where I made mistakes, and then it's kind of highlighted by, oh, if it's on a spot instance, then like I'm failing in these particular scenarios, and I shouldn't, and I should improve them.
That's kind of a nature of Kubernetes, right? You're not supposed, you should not expect things to run forever and ever, right?
Yeah.
At any given moment, things can be moved around, right? Shut down and created somewhere else and so on and so forth. The only thing that you get with spot instance is that you might be increasing the frequency of the things that are inevitably going to happen, maybe happen faster, right? But not much more. The one thing that I do like is a combination, right? You don't have to be locked into not spot or spot only, right? Those are not the two only choices. You can say, hey, you know what? I have this cluster with 50 nodes, and 25 of them are for specific workloads because those workloads are more more picky about and less resilient, and some others. I always have one replica. I have 5 replicas of my application. I have always one replica running on a normal node and 4 on spot and so on and so forth, right? You should be saving money. Let's put it that way, if you can.
And write better code where you can.
Oh yeah, oh yeah, oh yeah. Would you prefer to continue using Carpenter or transition to EKS Auto Mode? I haven't used EKS Auto Mode seriously yet, so I don't have the answer. I don't know what's your experience with it. I just haven't.
I haven't. I haven't either. I mean, I think that, I guess, philosophically, whatever the least pain is, when I spent some time with this a couple of years ago, there were serious problems with AWS's auto-healing capability. And and I think they got significantly better years ago. But in general, whatever is less load, I don't think anybody really wants to spend time in managing self-healing, or rather manually healing nodes, or even scaling them to the extent that your workload requires it. So I'm sorry, I don't know.
Me neither. That's okay. I have like six intermediary environments to production. Any suggesting strategies to upgrade managed Kubernetes to next stable version? First of all, when I hear 6 environments before you get to production, my head starts spinning. What are you doing in 6 environments is beyond my understanding, to be honest. I guess that and correct me in the comments, kind of that you have environment 1 and then you do something over there and then you move it to environment 2 and do something there. To me, that's too much, right? I acknowledge only production and maybe one more as permanent environments and everything else ephemeral environments. Oh, you have a pull request. You can spin up an environment, do your testing, do whatever, right? And ephemeral, yes, you can have any number of them. 6 real environments sounds too much, but I'm going to ignore that, right? How to upgrade managed cloud Kubernetes to next stable version. And I'm assuming by the wording that it means upgrading Kubernetes itself. And if that's the case, all the providers that I know right now, assuming that they're you said cloud, are giving you that option. When you upgrade GKE, AKS, and I believe EKS as well, it will upgrade one node at a time, right? So you will see if you have 100 nodes cluster or 10 nodes or 5, one will be shut down, new node will be created, and if it doesn't work, it will stop there, right? Now, if it doesn't work from the Kubernetes perspective, just to be clear, which rarely happens in case of managed Kubernetes. Now, what you need to do is have some kind of observability and alerting to notice, okay, so this is not going well. Our applications cannot handle this, right? And abort, essentially.
Yeah. First of all, I agree with your first point. Not that no judgment on how many environments you have, but I think anything that's not production or maybe pre-production should be ephemeral, and you could do whatever you want, break it, rebuild it, crash it, whatever. So hopefully that helps. At least with the complexity of upgrading. But also 2 things. One is that maybe going back to the previous question of spot instances, if you developed your software in a way that's resilient, then an upgrade should be a non-event, except for maybe that one node pool that runs those special workloads that are more stateful. And
in theory, if you go a few years back, it could be that you never tested the upgrade in a different cluster, and you were faced with the changes to ingress, which were changing every second day, and your ingress all of a sudden stops working, right? That could happen. But that's why we try it out first, right?
Yeah.
Okay. From Nikos, what add-ons you deploy usually in AKS cluster? I don't deploy any. And the reason why I don't think that they're bad necessarily. It's just that I tend to use multiple providers, and then like Prometheus or scaling maybe no. Scaling is a different story. But many of the things that I use in my clusters, I tend to deploy them not as add-ons, mostly because I want them running both in GKE and AKS, right? But if you're not using multiple providers, they're probably great. They're probably great as long as they're easier way to install something that you would install normally, right? If I see something AWS specific add-on that works only in AWS, I tend to freak out a bit.
Yeah, I do the same thing. So I've got like one GitOps pipeline that has like common components that are deployed in GKE, EKS, and Azure, and it gives me consistency. Like I know what I'm running, but I am self-hosting those services, and I made a judgment call that those particular self-hosted add-ons are not painful or not significantly more painful than trying to do the same thing in 3 different clouds. If you're only in AKS, then maybe it's easier. I don't know.
It also depends on the add-on. Like there are certain things that are very specific to a provider, like cluster scaling. It's not that you can deploy the same scaler to different providers and you say, I'm going to do that, right?
Yeah.
It will be very specific because it depends on infrastructure to a provider. And that's a good kind of, hey, if your provider gives you auto scaling through some add-on, go for it. Kind of like roll with it, fine. But Prometheus, like the only thing I'm not sure what you get through an add-on that is so significantly better than you have installed.
Yeah.
I'm not sure.
Yeah. I would, if anything, I would go with a managed service in the respective cloud that is actually outside of my cluster, because if it's a, maybe a managed Prometheus is better, so then I could use that.
Oh, yeah. Okay, so I think this is reference to my previous comment about development environments. Do you use Octeto together with MirrorD? I love Octeto, but I'm slowly switching to MirrorD mostly because it gives me both. It gives me everything I need to develop, and it connects it to everything else, right? If you use only Octeto, you would need to combine it with something like telepresence, right? That would still, because you're running your application, you're not going to run the whole system remotely, because that would be too expensive, 50 services or whatever. So if you, with Octeto, you run your application remotely, which is cool, but then you still need something like MirrorD. I don't think that MirrorD will work remotely, right? I don't think that MirrorD would solve that problem, but something similar you will need with Octeto, right? Okay, I think that this is reference to one of my videos where I trashed basically Crow. Have you looked at Crow again to understand if the problems you encountered previously have been fixed? Any updated feelings on Crow? First of all, I don't think that I published that maybe a month ago or something like that. I don't think that any project moves that fast, right? It's not that everything changed in a month. I did actually yesterday. I was using it again, and the problems are still there. At least the few that I checked again. So we need to give it a bit more time, I think, for that to be fixed. Okay. Codefresh did that. I did that course recently. Good stuff. Oh, thank you. Hi, it's me. Okay, that reminds me. There we go. Here's another banner. Oh, I need to remove the comment. Here we go. Yeah, go there. Learning.codefresh.io. Thank you for sponsoring. Use Victor as the code, probably somewhere, etc., etc., etc. Where was I? Yeah, good course from Codefresh. Did it recently. Thank you. Thank you for confirming. Because this is a bit awkward situation for me, because I'm not doing courses myself. I tend to kind of start playing with things long before they become a course. So I cannot judge it myself whether it's good or not. So this is a good combination. Usually, AKS, GKE, EKS, you make API public or private. And in case of making it private, how to access the cluster. If you use GitOps, you don't need to access the cluster for operations, right? It's a pool-based mechanism. It's running there. Is doing operations, and then you need access only read-only access for tools that are pulling information from outside of the cluster. Let's say observability, right? Assuming that you don't have it set up in a cluster and things like that. I don't know what's your experience, but I don't have a big problem with read-only access.
Yeah, I think that in the stricter enterprises that I've been working with, there is a strong reason to make it private, and then they kind of create some VPC and VPNs and whatever. Like, you could solve those problems, and in general, you would hope that especially managed cloud providers are maintaining the APIs, but there could be security vulnerabilities, leak credentials. So I think that if you're worrying about a production service, then it's probably a good practice with all the pains to run private API endpoints rather than public API endpoints. That doesn't excuse you from properly managing credentials. Just to be sure, to say that it's private doesn't mean that you should just have like static kubeconfig certificates flying around. Yeah, I mean, I think it probably comes down more to your service, your company policies, and in general, GitOps is a good thing anyway.
Okay, next one. Mohammed, do you think there will be a container orchestrator in Rust language which could be as popular as Kubernetes? I don't think that there will be an orchestrator in any language as popular in Kubernetes ever. What I do think is that something will replace Kubernetes eventually, but it will not replace it by trying to do the similar or the same thing just in different language or stuff like that, right? Whatever will replace Kubernetes will be something with radically different ideas, right? Because Kubernetes is so big that just replacing it with something small that is in different language but based on same principles would never fly, right? Essentially, all other attempts in the past, Nomad, Docker Swarm, and so Tupperware that nobody heard of, that they failed, and nothing can replace Kubernetes by trying to do the same thing. And I will die on that hill, right? That does not mean that it will not be replaced. It will. Somebody will come up with a very different idea how to do stuff, and then it will be replaced, but not because of the language.
I don't think, I was just going to say the same thing, maybe that it is not a function of the language. I think that Kubernetes, first of all, is an API, and it doesn't matter what language it's implemented in. If you implement the same API, there's no point replacing it or the same type of an API just because it's a different language. If you create a significantly different API that is better, then you can choose whatever language you want to implement it in. I think it's how you interact with your platform what matters.
And that's also important point. I feel that one thing is Kubernetes itself, but Kubernetes that you're using, that's a out-of-the-box Kubernetes plus probably just as much or even more of third-party controllers, right? And nothing prevents you from having those controllers in Rust or Python or Node.js. Kubernetes that could not care less, really, which language you wrote it in.
Yep.
Now, that being said, I think it's a similar situation like with data engineering or ML or AI, that, yeah, you can do it in any language you want, but in case of AI, Python is dominant, and you might not like it, but you will find more help with Python than any other language, right? And it's a similar thing with Kubernetes. You can write it in Rust, right? But you will have harder time getting everything and doing everything you need than in Go, simply because Go is the most common language for Kubernetes. Okay, here is Excalibur's comment. Better propagation would be really useful for crossplane debugging. And I like that, Excalibur, that you said better propagation, because I actually complained, I had the same complaint a while ago. And the result of that complaint is that within crossplane, we did do, what's the name? I forgot the name. It's a function that, I forgot the name of the function. Anyway, you can do propagation in crossplane. Now, it could be better, yes. But crossplane, as far as I know, is the only one that does that. Mostly because I yelled at people for so long that they said, we're going to do it only so that you stop yelling at us. How one is, and I'm really sorry that my brain froze. I don't remember the name. It pinged me later on and I'll let you know how. I'll show you examples. Okay, from Alex, how one is supposed to protect Kubernetes node using IP tables running on an edge compute environment, not cloud, without messing and affecting IP tables that Kubernetes already does? I have no answer for that. I'm not running anything in Edge. I don't know, you.
Not really,
Endre.
Not really, honestly. But how many things do you need to expose at an edge? What is the attack surface that you need to? How complex is the attack surface that you want to expose? So if it is a node, it can basically make an outbound call to a control plane. If it is making an outbound call, it could be controlled through GitOps. If it's collecting data, it could push that data out. What are things that you need to expose at the edge? Are you pushing data into something thing that is exposed at the edge, then it comes with some complexity. Can you do that through native policies, gateways, if you have to have such a thing, so that you're not fighting with Kubernetes, but you're kind of leveraging them? I don't know.
There we go. You know more than me about Edge, obviously. So there we go. From Scott, what are your thoughts about HashiCorp Boundary? I haven't used it. I don't know. I don't know if you use it, Endre.
No, I haven't.
No?
Sorry.
No answer. From Sam, Argo CD has become de facto standard for GitOps, but how about pipe CD from CNCF? Metrics like change, failure rate, deployment frequency, MTTR, looks promising. A video about pipe CD would be appreciable. Yes, I tried to enter into pipe CD a few times, and it always felt a bit strange. I need to give it another try. But I haven't used it really well enough to be able to answer. What I can answer is that I don't see the things like failure rate, deployment frequency, and so on and so forth as directly related to GitOps, right? You solve those things outside GitOps. GitOps is basically equivalent of, I'm simplifying it greatly, but equivalent of executing kubectl apply continuously, right? And you have something in a cluster that is doing all the other things. I don't know. I'm guessing you haven't used pipe CD, right?
I haven't, and I have to admit, I'm quite happy with Flux. I just think it works, and I don't have a reason to do something different because it's simple and it works.
I personally think that Flux architecture is, when I say Flux, I mean Flux 2. Flux 1 was horrible.
Yes.
It's better than Argo CD. I like it more. It's just that it is losing traction, right? So I'm not 100% sure that it will be able to keep up. Right, that's my worry about it. But it's better designed. I give them that. I mean, Stefan is absolutely amazing. Hi, it's me. What things that aren't metrics providers do you always deploy to cluster? Things like external secrets, Caverno. Yes, external secrets always. Caverno most of the time. Sometimes I go with Kubernetes validating admission policies. I don't know what else. My brain froze. Help me out. Argo CD for sure. I have some metrics for sure. You said aren't metrics providers. Cilium. Cilium is every single one of my clusters as well.
I think that it doesn't have to be a mesh, but some things that you want to expose, some gateway API gateway.
Gateway. It's a horrible name, isn't it? I'm always getting confused. This is API gateway or gateway API. I don't know which one is which. Just so horrible. I think we answered this one indirectly. What's happening to Nomad? It is pretty good, but can't make money without giving away the incentive to go for paid versions. I think it doesn't matter whether it's good or no. Nobody's developing anything for Nomad. You would be out of it. I think it's the same. It's even worse situation than ECS. Okay, Icarus, what are good avenues you would recommend for networking and knowledge sharing with other people in the DevOps and Kubernetes space? CNCF Slack, Kubernetes Slack, come to KubeCon.
SRECon.
Yeah.
SRECon is next week.
I mean,
come.
I actually, when I say KubeCon, I mean KubeCon or KCDs, right? For some people, going to a different country for KubeCon might be very expensive, right? And maybe out of reach. But if you cannot come to KubeCon, there is KCD around you for sure. So it's a smaller version of KubeCon. I don't have a preference. I don't know about you, Endre. Istio or Linkerd?
I personally have worked more with Istio, but that is not necessarily an indication of anything. I think Linkerd is leaner. I think Istio historically has been more bloated. So for some use cases, Linkerd is just simpler. I think Istio is trying to get there with ambient. So, but still, there is more overhead, I think. but I still like Istio. I don't know if I have to or nothing.
Yeah, I said I cannot answer that one. If the question is which one I like more, I like Linkerd more, to be honest. It's just a kind of leaner and it's easier to wrap your head around it. But the reason why I said I don't know is because on the other hand, it seems that Istio is going to become the thing.
Yeah.
But on the other hand, I feel that actually, service meshes were fighting with each other. Is it Istio or Linkerd or this or that, kind of like there are 50 of them. Then from underneath them, Cilium came and just kind of like messed up with all of them, right? And it's slowly taking over the whole. So I think it will be soon any service mesh or Cilium as they're extending what they're doing, right? People are using scripts everywhere in DevOps and cloud-related things. What exactly are they using with those scripts? For what are the reasons we need to write scripts? So that you don't repeat yourself?
Do you want to talk about declarative versus procedural stuff a little bit? Because that would be fun.
Yeah. So, actually, I have a very clear division, right? If I need to define a state of something, I like it to be the final outcome of that to be declarative. And I intentionally say final outcome. I might write my manifests using KCL, for example. That's my preference, right? But I output them to YAML and store them to Git in YAML, and the output is declarative. Doesn't matter how we get there. On the other hand, not everything we do, actually vast majority of things we do is not defining state, it's defining logic, right? And you need scripts for that. And when I say scripts, I mean not necessarily scripts as bash, but it can be Go, it can be Python, I don't care what it is, right? And I'm kind of surprised with this question because it's, in a word, DevOps. Kind of like if somebody as DevOps is questioning the need to write any code, I think we have a problem. And I'm trying to be polite now.
But I think one thing is that try not to write scripts for things that you could declare. It will be nicer.
Oh yeah. But there are many things that you don't declare. It's kind of you still write code. Code is not going away. Okay, so hi, it's me. Come to KubeCon. They say I'm in the UK and it's still just so much money. It's very expensive. It's very expensive. But again, in UK itself, there are probably 5 KCDs a year and bunch of DevOps days. There are many events that cost close to nothing or nothing, right? And also, if you happen to be close to London, come to Rejects. Rejects is pre-KubeCon type of event with a terrible name, and that one is free. I'm just not
possibly. And more fun, possibly.
Or not possibly. It's more fun.
Yes.
Okay, this is a question I cannot answer because I haven't used Terraform for years now. So I completely moved away from it. I don't know. I don't know how much you're using or not using Terraform.
But the thing is that it really depends on what you're provisioning. So, in general, thinking about minimum permissions is always a good thing. You should, but it depends on what are you provisioning RDS, are you provisioning EKS, are you provisioning, ECS? Different.
Yeah, but that's kind of that's the challenge, right? Let's say that I will put Terraform into 2 buckets. Somebody created a module, and I'm just instantiating stuff from that module, just writing values file, essentially, right? Or wrapper around that module. I'm not writing Terraform modules myself, right? And in that case, whomever wrote that module knows what are the permissions that it should have, and you're giving those permissions, and off you go, right? Why would you need more? Ignoring the fact that actually managing permissions is a pain. The other thing is that if you're developing Terraform, then nobody knows what permissions you need because nobody knows what you're going to put in there, And that's kind of a challenge.
But you should think about it. I think that myself included made the mistake of like, let's just start with full admin. Oh, it works. And then moving on. It is a good idea, especially when you're the owner of that, whatever that thing is, to say that like, okay, this is what is the minimum that I need, and it's documented, and it's part of how you expose your code.
Yeah.
Obviously.
And I tend to solve that. Again, I'm not using Terraform, but other similar cases.
Yes.
That problem that when I'm writing definitions of that something, in case of Terraform modules, right? I would use my own account, right? I'm an admin there. I can play around. Because I don't know in advance what I will need. So I'm very comfortable with admin my private account that kind of spends $20 a month, right? And then when you're finished, you say, okay, so what is this thing doing? It's doing this, this, and that. You can create roles that give you only that, and then you're done. Prometheus, Mimir, or Victoria metrics for medium-sized clusters. I don't know, what is medium-sized? Let's make a guess. What is medium-sized like? I mean, I've seen clusters that are 100 nodes, that are 10,000 nodes. I don't know what is a medium of that. Let's say 100 clusters, servers. Is that a medium? Maybe. But anyway, I'm in between Mimir and Victoria metrics. Prometheus is great, but it's probably, I think that we are moving towards better solution than Prometheus that use Prometheus format. I think that Prometheus format is important. And
I think that you want to get started, like whatever is below medium, it's okay to get started with Prometheus because it's easy. And then if by medium you're getting to the point where like this is actually at some scale, then Mimir, although I am using Victoria metrics myself, so.
But and that's kind of the beauty of it, right? If all those tools are expecting metrics in the same format, and the tools that will use it all also, like let's say you're using Grafana, are also expecting same format, there is no good reason not to start with the simplest one, right? Because upgrade change is going to be relatively straightforward.
But this is where the problem comes. Victoria metrics exposes things that you cannot do in Prometheus and Mimir, and once you start using them, maybe for a good reason, you're done. For example, pushing metrics with a earlier timestamp than right now is something that you could do in Victoria metrics, and apparently it's heresy elsewhere. But once you start doing it, anyway. So I don't know. Try to keep it standards, but then.
Yeah, but if you start with Prometheus and then progress to Victoria metrics, then you know what you can and you cannot do and stuff like that.
Yeah.
Okay, can you please do a video about Gatus monitoring tool? All the config is in YAML, amazing. I haven't used it, but I will put it on my to-do list. I don't know if you used it. No,
I haven't.
I'll try it out. Okay, this for you from Mohammed. Endre, can you say something about yourself and the company?
Sure. Okay. So this is not a pitch, but like since you asked, so we have built a platform that solves in software how to assure the reliability of your services. It's a reasoning platform that, based on observations, identifies where and what the problem is in your complex distributed microservices infrastructure, and automatically remediates it or hands it to an agent that can automatically remediate this. Today, a lot of time, I think, spent by DevOps people tracking down through millions of Grafana dashboards what they need to do. We want to lift that burden, solve that problem in software, and help you run better services. If you're interested, find me. Happy to go into more details.
Okay, from Arkady, what are the common scenarios do you need to consider when testing CRDs and operators? You want to go first? You go second? Or not go at all?
Testing as in developing and testing, or taking someone else's CRD and testing it?
Let's say that it's your own.
Yeah. I mean, the most obvious thing is that can I create, update, and destroy? And if the destroy doesn't destroy things, you've got a problem. And if the update doesn't update thing and you have to delete and recreate, you've got a problem. Create is easy.
Yeah, exactly. And I will assume that in this question means, because controller or operator can be anything, right? Can do literally whatever you want it to do. I will assume that this question means some kind of CRD, an operator that composes resources, right? Rather than do some funky stuff, some other stuff, right? In that case, yeah, what you said, I create a CR and I test whether that CR created something that I expected to create, when I update that CR, whether it updates, when I delete that CR, whether it cleans it up. What I can strongly recommend, I don't know if you tried it, Endre, Kyverno Chainsaw. Absolutely amazing tool for testing Kubernetes in general and especially CRDs. What do you think about SREs? They're cool people.
Yeah. I was talking to someone yesterday who said, like, there is this hidden corner and the only people who are brave enough to go there are SREs. I'm like, no, I think actually it's fun. I think that it's how do you figure out things that you don't have to do manually? How do you automate things? How do you get yourself out of a job? Which I think is actually true for any software engineering thing. Like, you want to write software that doesn't require people in the middle to, move the whatever wheels behind the scene. And if you can go to the beach and not worry about things, then you done a good job.
Yeah. I really, whenever I get asked about SREs, I feel that people are misunderstanding it, and I like to quote whomever in Google started it. I cannot quote, but paraphrase the sentence. It's how about we give developers opportunity to solve infrastructure problems, right? That describes SREs really, really well, or what they should be, right? Where do you see cloud DevOps in Kubernetes in next 5 years? Or should we move to AI, and how we can integrate or use DevOps in AI? First of all, I don't think that it's one or the other, right? It's not, or should we do cloud DevOps in Kubernetes, or should we move to AI, right? I don't know what's your view on AI, but my view is that in a foreseeable future, AI first needs to prove itself as a helper before we start thinking about replacing things fully with AI. Oh, I don't run Kubernetes anymore. Kind of AI is running it for me, or whatever it's doing, right? That might come, but I don't think that that's coming in the next couple of years. As a helper, yes, huge yes.
Yeah. But it's clearly not a choice. If you look at any one of the major providers, CoreWeave, Lambda, they are all running AI workloads on Kubernetes, and effectively they are, they're providing a cloud-like service, and there are people who have to figure out how to operate and automate and expose these in a way that are consumable. So it's not a choice. I think I am maybe slightly more optimistic, as in, you're absolutely right, it has to prove itself, but I think in the sense of being able to create things faster and easier, that is not a replacement, it is an accelerator in anything, including software development as well as DevOps.
Oh yeah,
in general.
Yeah. I was more referring to, the way I see it, AI, is that first, I want to get to the point that in vast majority of cases, what it tells me that I should do is correct.
Yes.
And then I can let AI do it for me after that, right? Kind of like, it's almost, I see it almost as, you hire somebody in your company, and at the beginning you will be reviewing that person's pull requests, right? But then eventually you might get to the point, kind of, you're good. Just go. You can push directly to the main line, kind of like you can do it in a way, right?
So maybe this is a bit of a sidetrack, but I think that what is really important for the evolution and the accuracy and the usefulness is to be able to create semantics if you think about, maybe this is a very far-fetched analogy, but if you think about Kubernetes, exposing an API forces you to come up with some semantics of what this means. The better we are able to describe the world semantically, the more meaningful the questions that we are asking from AI, and the better the answers are going to be. So I think that rather than assuming that raw unstructured data is the input and the output of the AI, at which point you will question the usefulness or the accuracy of those answers, the better we're able to define what are the semantics, what is this agent supposed to do, how am I supposed to prompt it with the right context, then my answers are going to be increasingly more valuable.
I haven't thought it about that way, but that makes so much sense. That basically, I'm going to put words in your mouth and you tell me how wrong I am, right? That actually we will see bigger success through structured API. AI is talking to structured API that has existing schema. It's well defined what cannot be done than, let's say, executing shell commands of random tools and piping it to random stuff.
Yep.
On my laptop, right?
Yeah.
Is that where you're going?
Yes, but in that particular, yes, but semantics are more important than syntax. Syntax is not important. The semantics are what's going to make this actually useful. And if anybody assumes that without any semantic conventions, we are going to, and I don't mean OpenTelemetry, I mean in general semantics of the definition of the world, you just throw data and you get meaningful, useful answers, they won't.
With that, we are out of time. There are a few questions we couldn't answer. Come back next week and we'll try to answer them. Thank you so much for watching. Thank you, Endre, for being a guest. You did great. See you next week.